Hello, nice to be back. I really must say I enjoyed very much this discussion yesterday and also the topics. And looking at the topics today, what you have already heard, I think this time it's even more like that speakers will maybe converge in some situations, maybe diverge in some situations. So I think really this conference is also showing that science can be as different as dog breeds sometimes, and maybe even more different. So my story will, I think, fit quite well with what Alexandra was showing before, although there will be differences. And this is another case, actually, where if you are invited to a conference, usually many months before, and you have the first thing what you have to do is to supply a title to your talk. And then, of course, you're thinking about a fancy title. You know, Clive was also talking about this yesterday. And then I came up with this title, which is, in this case, what dogs could not lose, what they never had. And since then, actually, I'm still thinking what I really wanted to tell you with this title. So maybe you will still have at the end of my talk, you know, you have a private answer, subjective answer to that. But I think the idea is, again, something similar what Alexandra was trying to say about this thinking in an anthropomorphic way about cognition, about dogs, about how mind functions, and so on and so forth. So this is the general attitude which I would like to expose. And then, of course, at the end, I would like also people, hopefully, if they go home thinking about that, try to hope in improving critical thinking about these issues. So. Again, just a short outline and basically also the take-home message a little bit in that regard is really how I would like to talk a little bit how mind operates. And given that I spend now quite a lot of time in science, I must admit that my thinking about how we should, how scientists should think about mind and investigate mind has changed a lot over time. So I would disagree with a lot of things which I probably said 10, 15, maybe 20 years ago. And probably I will disagree in a few years' time what I'm saying you now. So don't take it so seriously. But still, I think we are in a situation where we have now, for unsolved problems, and this is a short estimation, for at least 100 years, probably it's 200, probably it's more, if you count all the philosophers who were thinking about these sort of issues. So, and sometimes I don't want to exploit very strictly, but I have this feeling that we are still on the same spot. So we didn't really move in either direction too much, or at least it can't be seen very well. Then I will a little bit talk about how we try to investigate this problem, how we can take a world view from the dog's point of view. And actually, I would like to suggest that we are not talking so much about mental processing, cognitive ideas, but being people working on behavior, basically, we might actually have a different type of language, which starts with saying that we are investigating problem solving. So the problem of problem solving, that's actually the real question, what we should attack and investigate. And then I try to end with a quite concrete problem of investigating the problem of tracking objects, which is a problem. I hope I convince you that that could be a problem, especially for dogs, but sometimes also for humans. So this is the slide I had yesterday, and the only change to that slide is that I managed to put over this slide is in red. I hope you can also read it. I, of course, know that red is a warning color, but actually on a PowerPoint doesn't make much sense sometimes because you can't read the text. But what it says is that even though we will start out very often with this model of, or we, by we, I mean our research group, with this model of social competence, we don't and never really think and never take it very seriously that the mechanisms underlying this social competence should be same, actually not just between dogs and humans, but also including other animals. So that's just the bottom line where we can start from. Now, the other metaphor I like to share with you is this, what I always use also when I try to explain students all the problems which occur if you want to study mind. And the problem is that the people who are studying mind that are living in a particular world, and how they perceive that world, it will influence, unfortunately, I think a little bit at least, how they think about mind. And if you go through the, let's say, the philosophical history and also sometimes the biological history or psychological history about studying mind, then you will see that in different times people came up with different metaphors about the mind. For example, we had this nice metaphor, the mind working as a clockwork. And of course, interestingly, this metaphor originates from those times when actually people were inventing clocks. And actually, if you are going to a museum, because probably you don't find these classical clockworks now anymore in your homes, and you have all these digital things that nothing happens inside, but actually what you can actually see. But if you go to a museum and you can observe a clockwork, I'm still amazed how, let's say, 500 years ago or even earlier, people could put together, such fantastic fine instruments that were actually measuring time up to the second. And they were precise for many years without needing any improvement or repair and so on. So obviously, the logical argument was, if you want to understand mind, then the mind is something, the most perfect thing which I could then imagine, which was a clock. Then, actually, it was the end of the 19th century, the mind was working as a switchboard. And probably you can't imagine this situation when you were calling your friend. I mean, now it's fun, everything happens automatically. I mean, people twittering and sending messages back and forth. But at that time, if you want to contact somebody, there was another person who actually made the contact. So there was an incoming call. I told him, I want to go talk to this and this person. And then somebody actually made the connection. Now, this was a nice invention. It was still quite complicated, so people came up with the idea that maybe minds are working like a switchboard. And then, I don't want to make the story very long, you could have the same metaphor with a computer, and now, what is the best and most fantastic invention of the modern time is the internet. So, there is no way that we can otherwise explain the mind as being a fantastic network that works just like the most exciting invention of our times. So now we think about the mind as being a complex arrangement of network and so on. So the basic idea here is that how we conceptualize our mind depends very much on how we perceive the world, what we are living in. And of course, there is this very nice distinction that you can also have, especially that goes back to the computer or the internet, that there are these hardware components which you can represent by genes or neural tissues, and there are these software components which could be represented by thoughts and states and whatever you want to call them in the mind. Now, again, I have to introduce you to another historical problem, and this problem actually relates to a very famous man actually in Eastern Europe, where I'm coming from. So this was a bit advertisement for that part of the world. Farkas Kamplan, actually interestingly, his first name, Farkas, means actually wolf. And that time it was but it has nothing to do with dogs and wolves actually. And he was an inventor. If you see the time, this was a time of inventing a lot of new important things. And actually he was inventing, among others, because he was interested in speech, inventing a manually operated speaking machine. So that actually you can, with some specific arrangements and using air, he was able to produce different sounds by this machine, which was quite exciting. A more practical thing, what he was also inventing, was inventing the typewriter for blind people. And the whole idea of writing by the means of a machine was actually at that time quite new. So he did a lot of things that are probably also useful today. However, what he was famous for was the chess-playing automaton. It was a machine that you could play chess with, and the other very nice thing about this machine was that he always win. Now, you can imagine that at that time, I mean, there were no modern computers and nothing. I mean, it was really a puzzle. And it looked like that, you can imagine, but like a big box, and you actually had even a person there. I mean, it was a machine, it was a Turk in a nicely color coat, and nicely, he could also move the figures on the table and so on and so forth. So everything worked perfectly. And what actually he also managed to do, and he was you could look at this little box, and there were everywhere these wheels turning around, and he gave some noises, and everything was working just like a clockwork or something. And it was very clever because, as you see, as is documented, the machine usually always won. And he was bringing this around in Europe, and he collected a lot of money with this and make amusements. At that time, there were no TV, no shows, and whatever. So, you can imagine that was a quite of exciting times. Now, the only problem was that many years after actually he used this machine, it turned out that, the solution to that, all this is that actually there was a little man inside the box, and he was hidden so well that the trick actually was never really revealed at that time when he became very famous with using this machine. So, and this reminds me always about this problem, whether we really, when we're investigating the mind, whether we don't really what we are actually doing, we are putting a little man in that mind, and this is what we're investigating, and not the mind itself. So basically it's about how objective or subjective you are when you are looking at cognitive problems, how the mind really works. So, after this, giving you this background thoughts about these problems, I just want to show you another way how people are approaching this. And of course, if you're doing a sort of introduction about dog mind, it's good to have the definition, how scientists think about this. And there are many scientists, there are many definitions. Here are two actually. One is from Mark Beckhoff, who probably would agree that actually I copied from one of his papers, when he defines mind in a way, and the study of mind, that you are studying thought processes, consciousness, emotions, beliefs, rationality in animals. You could also include humans here, based on Darwinian continuity. And you can remember, when he was talking about these issues, actually he was using these words, referring to the mind and referring to them as subjects of study. So you can study these concepts if you like. Now, of course, I think if you want to be more operational, then it's much better to use this definition by Sarah Settleworth, who actually is one of the leader cognitive ethologists or comparative psychologists. I don't know how she prefers to be called, but anyway, how she defines mind is actually something which more reminds you to this computer metaphor, where you have something that is actually able to acquire, process, store, act on information that originates from the environment. So both definitions are actually quite broad, but one advantage of this computer metaphor-based definition is, I think, that it tries to distance itself from very much human-based concepts. Why I'm trying to saying that is that, and this is probably, of course, not in this community so a huge problem, but if you are studying animals and a wide range of animals, especially in terms of how their mind functions, there seems to be that people are falling very often in two camps. I mean by people, the scientists. And scientists are one side, they want to prove that animals have some sort of complex abilities. And on the other side, you have scientists to prove that everything what was proven by the others could be explained in a very simple way. Now, this is what I call the one group of people would be if they would have a sport club, they would be called like the trophy hunters, and then they are playing against the killjoys. Now, I think if you are watching football or soccer or rugby, American football, for example, also, you can enjoy that. And I'm not really watching it for a long time because I'm not enjoying it, but I can understand that people are enjoying that. Now, for me, watching this game actually after 100 years sort of becomes a little bit boring. So I think we really should change our views here. But I really want to illustrate also subsequently that's not easy. So it's much easier to change the game, or at least doing something else, than actually to make this change happen. And the reason for that is that there are these clubs, if you like, they have a very long history. And Just like in football, I mean, I always telling my son when he goes to a football match that he always is dressed up in a red, actually green scarf, because it's the green, the color of the sport club he's a fan for. But I don't understand what makes the color so important, you know? So. But it's important because of the history, because, you know, it goes back 100 years ago. So it's the same in science, that you have these colors and you carry them all over and you inherit them to the next generation. So one of these colors are coming from psychology, it's called. This is a color, in a sense. A tradition, how you think about problems, versus ethology. And in the former group are thinking about the mind mainly in terms of human concepts, and they really try to make this argument, or used to make this argument very clear, that there are humans on one side and all the rest, animals, whether they are fish, insects, or dogs actually, are on the other side. And some of them even claim that all animals are equal in that sense, that their mental abilities are more or less of the same. Of course, there are little differences, but that's not so exciting, especially if you see it from a human perspective, because we are so different from all the others. Ethological thinking, or the ethologist club, would claim actually that it's not like that, because, you know, and we talked about this along for many times, there is evolution, there is adaptation, changing environment. So minds, actually, animals might be quite different from each other. Of course, they are different from humans, but also within animal variability is also large. This is one. And the other is these other two clubs, which actually are sort of merging, and there's not a clear distinction who belongs to which one. I mean, these you can play against each other, but it's difficult to explain it other ways around. That some people actually like to talk about mind in a very simple terms. Many years ago, they were simply called behaviorists, going back to the old traditional psychological history, and they talk about what they call low-level associations, basically a stimulus-response association, and so on and so forth. And others who are calling themselves as more cognitives would be talking about more high-level processes, associations, or they would use the word representations, and even representation of the mental state of the other, like mind reading. So that sort of abilities, which are very high-level concepts when they try to understand the functioning of the mind. Now, these two clubs, when they play against each other, it's a very funny game, because what they do is actually they argue about these four words. And the idea is here that what is better, to have a simple system that can make complex things, or actually you need, if you are doing complex things, you have to have a complex system. And this goes actually also back to the Morgan canon, who actually, or the Lloyd Morgan said that you have to, or should actually, interpret behavior and many other things actually in the simplest way when you can. And this debate goes on for many years, because not everyone agrees actually with his suggestion. Now, just to give you one example how difficult it is in reality working with these problems in the field, doing research, I would like to show you a little bit illustration about, one will be our work, and then I would a little bit talk about Monique's works, and I hope she didn't mind it. Maybe she can correct me later if I'm doing something wrong here. So the argument, it was, I think that there's no date, it was 2004, and we got interested in the same concept, but Alexander actually also mentioned, this attention. And just to give you a little story in the background, when we finished the paper and sent it to a journal, the paper title was, Dogs Show Situation-Dependent Recognition of Human Attention. And then the editor wrote us back, well, it's a nice title, but quite boring. Could you not make it a little bit more fancy? So I had not much time to make it more fancy. I thought, I was a bit sort of angry, why is a scientific journal, why do you want to have fancy titles? But I understand that, editors also have to sell the journal and the papers. So I had this title, luckily with the question marks, are readers of our face, readers of our mind? And she was happy with this, the paper accepted, so we just moved on. However, actually the paper is really about this, what you can see on the other side, how dogs can relate to attention. And here, as you will see, attention is not necessarily the internal process, but actually what I'm or the human is doing when he's attentive or not attentive. And actually, if you now take the recipe from science seriously, and we did it because we use the work from Joseph Cole, who is a very famous, well-established cognitive psychologist in working with apes and dogs and other animals in Leipzig, Germany. So this is his argument, what we used also in this paper. So first of all, attention is important in recognizing the other, and also, of course, if I want to send a signal, I should know that the other is actually watching me or attending me. So that's a function that could be important. Then you can have two hypotheses, what Joseph tells. One is, which he calls a relatively simple idea, that basically what you're doing is you always learn about behaviors that signal attention. So for example, eyes or head orientation, body orientation, or whatever can be a signal for attention. So there are behavior cues. And basically what the dog or the chimpanzee or the human child is doing, or we are doing, we're just doing these little learning tasks, and then we decide that if we see two eyes, then there's attention. If there's no two eyes, there's no attention. But actually, I'm not thinking about this attention. I'm just thinking that if I see two eyes, I give my signal. If I'm not seeing the two eyes, I don't give a signal. Now, the second type, that would be the low level, the simple mechanism. The higher mechanism, the more complex one, is that actually what the mind is doing is able to represent the attention as a state of the other. Now, how you can do it, of course, is quite complicated, but the idea is basically that what you are doing in this case, I mean, this is how I can explain it in a language terms, that I take the other's perspective. Okay, so I step in your shoes, and if I'm seeing that you are watching, then okay, now that is what I would do in this situation, so I understand what's going on. So this is how I represent attention in that very simple way. Of course, what it also means that in this case, the attention is quite context-specific. And in this lower case, attention is a general concept. So it should be independent from any situation, because if I have this ability to represent attention as a state, then it shouldn't matter what sort of behavior I see. I can always understand it in terms of attention. So this is the logic what you try to disentangle, so find out which might be true or not. And then we did an experiment with Marta. Actually, she did this experiment. This is now just a few videos. Can we play it, or? Yes. So the idea was we play with dogs or interact with dogs in different ways. She threw a ball in one direction. The dog can picks the ball up and then approaches Marta. And what you can also play, we also see in the next sequence that when the dog is now running again in this direction, she will turn around. So basically, either she remained in the same body position, or she actually made a body turn, and we also varied whether she had a blindfold over her eyes or not. So basically, this was the arrangement for this experiment, but we also have had other conditions. I just show you the chair condition, which is basically that now this is a common situation, so the person gives a ball to the dog, and it gives the command that he should take the ball to the owner. And here below you can also see that now this is another condition where the owner is turned around and the dog, in this case, approaches it from from the front. So this is how we played with this in this situation, looking at whether the dogs can discriminate between the context, and of course the idea was that if they recognize the behavior, they should approach the person always from the front and not from the back. Now, now we can skip this. What you can see here, these are the three conditions. So this is the play condition, then this is a chair condition, what is here portrayed, and there was another condition, sitting on the ground, which is actually just the same as here, but there's no chair being there. And what you see here, here's the sort of what you would call the success. So when it's 100%, that would mean that the dogs always come back at the front, from the front with the ball. And what you see here, that when in the play situations, actually dog doesn't seem to care too much about whether the owner is facing or not facing, but they seem to be caring much when they were giving a command, and they could approach the owner, then they were more likely actually to approach the front of the owner independently of the position of the owner. So our conclusion, first the conclusion is that yes, dogs can attend or can recognize that behavior has changed. So if you like, the attentive behavior of the human changed in these situations, but it's context dependent, because if you are actually playing with the dog, then they don't seem to have this idea that attention of the owner is important. And I think for you it's not really surprising. If you go to a dog park, what do you see? People are playing with the dog, they throw the ball, the dog runs away, then the people are talking with their friends or doing something, and then the dogs come back and the person is doing like this somewhere, where is the ball? And they don't really pay attention, and the dog also doesn't pay any attention. So habitually they have this interaction, but dogs are actually learning that, I can come from wherever direction I want, they will pick up the ball, and the play can be continued. So I think, again, here the habitual behavior gets interfered with some sort of more precise or more precise behavior, when in this case is actually the dogs are really able to base their behavior on the behavior cues what is given by the owners. So actually I was really happy to see that Monique and Clive and others did a similar study a few years later, actually using very much the same approach, although they started out with a little bit different type of discussion, because they were arguing that there are many references that suggest that dogs have a theory of mind, which I'm not really sure that it's really there, but anyway, we can also start from another direction. But they also came to the conclusion that it would be a nice way to using that sort of task in order to find out whether this perspective taking, or however you want to call it, exists or doesn't exist. So actually they described the logic of their study in a very much similar way that I was introducing based on Josep's logic. So they said that, okay, we do the perspective study, as you will see, it's a little bit different arrangement, but basically leads to the same conclusion. And then there are two humans now, so one is attentive and one is not attentive, and the idea is that the dog should select the human that is attentive and then get some food. And what they also explain actually when they write the text, they say that one person who is the attentive person is actually not able, the inattentive person is not able to see, but that's of course our interpretation, what we say that they are not able to see. We are not knowing whether the dog also understands what this really means. Probably what we can see from outside as an experimenter is actually does what they also say, that the subject, in this case dog, must respond to cues of human attention when they want to get the food, because they will get the food only from that person that actually is attentive. So again, here's this interesting thing that we know something more about the mind, or we attribute something more about the mind, what actually we can find out doing these experiments. And actually, the good side anyway was, here is the experiment arrangement. So here now are two humans. One is, I see here from here turning her back to the, I think this is a wolf maybe, I'm not sure. And this is a facing human, and in this case the animal is making a correct choice by approaching the facing, if you like, the attentive human. And but these are one condition, so this inattention could be checked by turning back, reading a book. There were many other conditions, and here are different groups of animals, pet dogs and shelter dogs and wolves, and actually that's not really interesting in detail. What is interesting, first of all, that if you look at all these data, it seems to suggest that generally most animals are sensitive to these cues, so they can make the choice going to the that person that actually showing the cues for attention. But there are some exceptions. For example, wolves are not so good and shelter dogs not so good in a case when they have to choose between an attentive person and an inattentive person who is actually reading a book. And you can't really see the eyes and the head and so on. So their conclusion, although it's a little bit written in a complex way for me because it's double negation, but anyway, what they say is that there is context dependency here again. So what we find here that, yes, sometimes the dog seems to be able to show sensitivity to attention, other times not. Now, the good thing was with this paper that after this paper, scientists had a chance to comment on that paper, which actually is sometimes very nice because now you can compare thoughts of different people on the same problem that was presented. And scientists came up with various ideas how you can interpret or what they think as important in this study. And this, I think, is very revealing looking from outside. So actually, what Range et al., a group of people working in Vienna said that, well, what this study actually shows us is that dogs are able to generalize to novel situations relatively rapidly under these circumstances. So for them, this idea of generalization is the most important. Then we actually, with Josep, together said that what we see is actually something quite similar because what you see that the reaction of the animals were influenced by age, reading condition, and treatment, and experience, and so on. So again, we said that everything what you see is very much depending on the context in which you investigate it. Then Roberts and Macpherson said that actually that's not so exciting because what we are seeing is outcome of relatively simple learning processes when the dogs are learning these particular cues that are signals for attention or inattention. And Alexandra said that for her, what was most interesting is that maybe that sort of problems, what we can see here, actually should lead us to revise our ideas about theory of mind. And she suggested that maybe we could introduce something which she called the rudimentary theory of mind. And I was happy to find out that this thought, I mean, she's not alone with that sort of thinking because actually some other philosophers talk about very much a similar thing using different words, talking about for Bermudez, suggesting that maybe for animals we can have something which is called a minimal mind-reading ability. So basically something what is not mind-reading as we understand it for humans, but something different. So I'm just showing that I don't really want to take sides. I'm just showing that it's actually not easy to agree on the same phenomenon when scientists are coming from different different background, different perspectives. They might have different goals, targets in their research. It's quite difficult to see what is really important in this research. So actually, when I was at that point preparing my talk, I had this idea, which I'm sharing with you. So you know that sport, which is a clay pigeon shooting. I'm not sure it's very, I'm not these people, you people know that very much. It's actually an Olympic game. The idea is here that you need two persons for this. One person is having this little cannon or whatever it's called. It's shooting, it's actually not a pigeon, so don't have to be, it's not about killing pigeons. It's not a living animal, but it's still called a pigeon. I mean, that's human fun. For a hunter, maybe, I don't know. They still have the same emotions, maybe, if it's called a pigeon. Anyway, but it's made from clay, so that's the most important. And then, so he's shooting this thing in a special way, and then there is the hunter, the sportsman, if you like, and he tries to shoot it down, and if it happens, then everyone is happy. Now, in spite of this, I have this other game, what I would call the clay mine theory shooting, which is an analog to that. So what scientists are doing at the moment is that some scientists, this is another one type, they are having it's now a mine, so an idea, and other scientists try to shoot it down. And so basically the idea is that, and I'm not sure that at the end both are actually happy. Probably neither is happy. So you win, you lose in both sides. It's not so enjoyment like the other one. But I think this is a nice portrayal of the situation that we are coming up with a huge theory at the beginning, a very complex one, and then we reduce it, and then we get to the situation where we say, okay, but that's just not really interesting, it's so simple, and then we move to the next one and try to then have another clay mine shooting, and then, it goes like from one step to the other. So And this takes now place for, I think, 100 years, more or less. So when I could argue very much, or I would like to argue in this direction, that collecting scientific evidence based on human concepts is quite a tricky one. So when we're really starting out with our view of mind and our subjective or even objective experience, if you like, about how our mind functions, then really that could be a problematic, I think. And I also think that when we try to change or giving other words to and new names of concepts that we even don't understand from a human point of view, that doesn't help either. So talking about mind reading, it's already mind reading is a quite complicated issue. Now talking about minimal mind reading or whatever, that's another, it doesn't really help in that sense. It just makes another, I think, the problem sometimes more complicated. And partly, this is what I also tried to underline before, is that in order to make the experiments at minimally working, we really have to, unfortunately, reduce our experimental word, and sometimes we reduce it actually too much in order to understand, but I think doing this reduction, we are losing the perspective. So, and when I was thinking about it, I came across this model by Ashby, who is actually a cybernetics, and he was interested in machines. And actually, his idea is that a machine can be stable only if he, or in complex environment, if he has the specific number of inner states in order to function. Now, this is, I think you can assume that animals, dogs, and even humans living in a complex environment, so they have a large number of inner states that exists in order to function. Now the problem is, if you reduce the environment in an experimental setting to a very small possibility, so the animal can either go left or right, or he can say yes or no, then what you are doing actually is that you are restricting yourself from getting to those let's say, complex level of inner states, what you want to investigate on the first place. So basically the idea is that, because just here's an example, so there are many more states probably or possibly in the mind than actually behavior that you observe. And then the problem, of course, is if your observations are so limited, how can you observe, or what is the chance to observe these complicated inner states? So if you are looking, we had these examples many times, you're looking, or you can see a dog is watching you pointing in one direction. The dog's mind, in principle, can have hundreds of states, which is, for example, the finger is closer to the ball, he points at the ball, he wants to point at the ball, he wants me to realize that he points at the ball. That is, it's theoretically everything in the mind of the dog. Now, what I am measuring is actually he goes left or right. So I think just by reducing the problem to the level where we can understand it, we actually just throw out the baby a little bit with the bathwater. So I think this is the struggle of scientists, and therefore, really, in name of others, probably, I can also say that we need more patience from other people in order to sort this out. So how we can deal with that sort of problems, I think that the traditional approach is what is now going on for 100 years, 150 years in laboratories is not sufficient for solving these issues. So therefore, actually, a few years ago, I decided to talk about problem solving. And problem solving don't have mind, you don't have attention, and many other things. And maybe I go along with this comment, we don't have time to talk about it too long, from Byrne and Bates, to talk about when you're doing problem solving, it's still valid, I think, thinking that humans have problems, so dogs might have the same problem. But in this case, you have to be strict that this argument from a human is again just a hypothesis, or even just to give you some ideas about what you want to study, but you don't take it too seriously. So in order, when you approach this problem from problem solving, you're actually removing or trying to removing this anthropomorphizing a little bit from the research. And you can come up also with a definition from problem solving, which which is something defined at the level of the behavior, and you could refer to that as something which is the animal makes changes or decisions in accordance with changes what take place in the environment. Okay, so one example, what I want to show to you is about problem solving. It started out actually as a physical problem solving, but it seems to be again that this is why problems are not coming as you might see them. So the problem solving in a physical problem solving is about hunting. And you could say, okay, what should a predator know when he's a hunter? What sort of problems are hunters facing? And here is a short list. I didn't want to go into detail. It's a very simple list. One is, for example, following trajectory. So if you are running after a rabbit, it's first of all good that you know which path the rabbit takes. But for example, if the rabbit starts to make in a curve, then it's actually good to intersect her or it or she or him, and therefore it's good to calculate where she will be in 1 or 2 seconds. So that is another important feature. It's not so simple actually than you might think, but that's another one possibility. Another important feature is that you have to find the rabbit if he disappears or it disappears, for example, behind a bush. So if, for example, it's running rabbit, and then you don't see any rabbit anymore, or the rabbit anymore, but you just see the bush, then the question is, what you're not doing? First of all, you can say that rabbit disappeared forever, so there's no lunch or no supper, you're going home. Second, you can imagine that now, and this is a strange place here, rabbits just turn into bushes. Well, yeah, what can I do? Maybe next time, maybe I'm faster. Second, you can still think about this, that maybe the rabbit is actually behind the bush, so you take the chance to go and look at that, and so on. So this is, again, an ability, and I think one reason why dogs still exist, because they are able to do that mental computation somehow, so they realize that, when also, of course, wolves can do it, that objects, when they disappear, they can still be there. This actually was called object permanence. Now we give it a name. But the idea, what is important here is that object permanence is a concept, and that objects are permanent is a physical sort of fact. But how we represent this permanence in our mind, that's probably different from how they actually are in the world. So anyway, these experiments go back to the 90s. And the French in Canada, in Montreal, researchers were long studying this effect for many reasons. Actually, this is the setup, usually what they use. There are some occluders here, and here you can see this little container that actually moves an object first behind screen A, then screen B, then screen C, and sometimes the object is shown. I will go into detail in a minute, and basically the task of the puppy or the dog is to find the object after this short demonstration. So these experiments actually go back to the very well-known developmental psychologist Jean Piaget, who looked at this problem on his children, and he designed a sort of series of experiments how you can test it. And this goes from a relatively simple situation to a relatively complex one. So for example, a simple visible hiding is that you hide an object behind the screen, but a little part of the object can be still seen. So this is a very simple task. Then the next task is that you actually hide the object one or many times behind the screen, one screen, and again, the subject is allowed to look for this object. Now, interestingly, when you repeatedly hide the object behind one screen, and then visibly hide the object behind another screen, then children, in Piaget's work, they're making an error, what is called scientifically to speak, A not B error, because this is the A screen. Actually, in my drawing, it should be now AC error, but doesn't matter. Usually, it's actually 2 screens what they use. So basically, it's an A not B error, because the children making the error that despite seeing the object being hidden here, they will look at the former place. So they're making obviously a stupid mistake, if you like to make this interpretation. I'm sorry about the children. Nobody remember. You did all these mistakes when you were 9, 10 months old. Don't worry, me too. Okay, so especially if you were in Piaget's lab. Anyway, so then you can make it more complex, like a sequential hiding. So you hide behind, hide the object here, then you can move it visibly to that location, then hide it again, and so on and so forth. And again, you can allow the subject to search, and so on and so forth. So what is important, actually, that children, as I told you, making an error here when they are about 1 year old, sometimes a little bit younger. But interestingly, in the setup that was used by Gagnon and Dumas, dogs were, and whether they were puppies or adult dogs, they didn't seem to make the error. Now, the problem, of course, for us was taking our own hypothesis very seriously about social competence, that if dogs or children are sort of similar in their performance, they should not differ in this case. So, I mean, I now helping you in finding out what might be the problem, but this is how an experiment was done, as I showed you before in the Dumas lab, and this is how more psychologists are doing that sort of experiments in a human or a baby lab, they call them baby laboratories. Do you know, I mean, probably now people can be aware. I can also, of course, tell to save some time what is the major difference in these two setups. And actually, if you read in the paper, it's not evident that this is a major difference. The major difference is that here the objects sort of moving are self-prepared, if you like. So the dog's perspective is here. So although there's a human actually doing the movement, the object moves alone without any direct human interference. But here, it's actually quite practical that a human is actually doing all the manipulations. So she's doing the hiding in the first location, and then she will hide the object at the second location. So the involvement of a human is quite different in this case. So we came up with, together with Joseph Topal, the hypothesis that maybe this difference what we see here between children and dogs is not a species difference, or what else it could be, but actually is the difference how the experiments are carried out. So Joseph then designed this experiment where actually we now controlled for the context. And in this context, we had what we call a ostensive communicative context. This is the context what usually is used with children. So when you have the experimenter and she explains, so to speak, even verbally, she makes the child attending, he talks to the child and shows what she's doing, hiding first the object under the cap, and this is a little cup turned over, here 3 times, and then in the trial bay here 3 times. I will show in a video with dogs later, so just explaining because the videos will be short. So here in the second condition, that was a strange situation, was never really done in experimental in experiments, where we had what we call a non-communication situation. So the person was there, she was doing the action, but there was no communication with the child. We still tried to make the child interested in the situation, but this was not done by verbal interaction. And then we had the third situation, which was quite similar to what the dogs were tested in, where the objects were moved without any human intervention in this case. And in each case, what you have to remember is that 3 times the object is hidden in the first location, and then 3 times in the second location. So that's how the experiments are running after each other. So, and for the case of the dog, this is what you see on a video. So this is now the ostensive communicative situation. So the experimenter picks up here the bowl. You can't hear the sound, but she talks to the dog, short words, listen, and so on, and then she hides the ball behind the first occluder, and the dog is released, and dogs can do, I mean, this is not a surprising, children and dogs can do that task. Now, here's the trial B now. Hopefully, if the video is the right one, the experimental again goes, picks up the ball, goes behind the screen, then shows the ball again to the dog, and now she hides the ball, hopefully behind the screen B, and she comes back. And this dog experienced already this condition 3 times, and the dog seems to make, or at least this dog for sure made this error, what we were seeing also in children. Now here's this other group, what we call a non-communicative group, where again in trial I1, what you can see is the dog is showing exactly the same hiding, but now the experimenter shows his back, basically indicating as little communication as is possible in this situation, but still trying to make the dog interested in the case. And of course, now the dog is okay. He can find the ball where it was hidden. Again, this trial is repeated 3 times, and the 4th trial, which is a B trial, so now the object will be hidden behind the other screen. So she is now showing the ball again and doing the hiding, and she comes back and shows the empty hands to the dog, and the dog can make up his mind where he wants to go. And in this case, yes, he goes again to the right place. And in the last condition, so this is what we call the non-social condition, which is the original replication, sort of what the Canadians were doing with dogs. Now you have to be careful because you can't maybe not see well. The ball is somehow here. The experimental we do similar behaviors, but the dog, in the meantime, the ball moved along here in this case. I hope you could see it. Now again, this is now repeated 3 times, and here's the ball. Again, the ball slowly will be pulled over to the other screen. The dog can follow it, and now it disappears, and the dog is let, and then he can make up his mind and choose. And luckily, we could also replicate the results from Dumas and Gagnon, so we were also happy. So actually, if you're now comparing and looking at the results, it's quite interesting that we understand something about this process, and it also tells you that although we started out being an experiment of a physical problem, it turns out that sometimes physical problems and social problems come together. So actually just reviewing the results is that children, if they're 9 months old, then they're making the A not B error, just as shown by Piaget and many others, when there is communication going on between the experimenter and the child. And just to take the other extreme is that if there is no communication, so the situation is as non-social as it is possible, so basically there's no human involved, nothing, then the children are much better actually, and in the B trials they can also find the ball to a much higher degree as they did in this situation. And you get actually in a different way, but you can also find the same results with dogs. Here what you have to look at is this. Now this is this bit other way around. So here we have preference for location A, location B is on the top, and these are the results just for the trial B. So dogs making the A not B error again, so they prefer the former location during trial B when there is a communication going on and intensive interaction relatively between the experimenter and the dog, and they are not making the error, so basically preferring the correct location, the location B on trial B, when there is no communication and no social interaction. We were also interested in how this applies to wolves, and we didn't have too much access to wolves at that time, and so therefore we had to do it a little bit differently, but also we repeated, we had again dogs as a control group, so dogs and wolves were treated as similarly as possible. And I forgot to tell you that this was done with bows, and with the wolves, of course, bows doesn't make too much sense, so we had to use food also for the dogs and for the wolves. But basically the results are very much the same. Here we just have 2 conditions, so the communicative, social and communicative, and the non-social condition. The dogs again showing this difference in this situation, so they're making the error, if you like, when there is a social interaction and communication. For the wolves that were socialized and all that, they don't seem to be so much interested in this, or at least there's no difference in this case whether they are in a non-social condition or in a social condition. So actually what happens, how you can interpret this, and actually on the one side for us it was exciting to find out that Well, here is a situation where we could also a little bit change the way how maybe psychologists are thinking about this particular developmental problem, what happens in children. So basically, comparative investigations in animal cognition, comparing humans and dogs and so on, is not just in a one-way business. So we're learning from humans and we are getting concepts and understanding from human behavior, but actually also from animal behavior. So I think it was therefore interesting for us this as an experience. But on the other hand, what was probably the less exciting but still important outcome, that really the dogs and the infants are very sensitive to the communication, to the interaction part, what's actually going on during that sort of demonstrations. Because actually, if you're going, I have to just go back rapidly to that, this is what you see here is actually a clear demonstration for the infant, for the dog, what's going to happen. So, and the person, so this is actually not really about disappearing objects only, it's actually about what the human, in a way, tells or suggests by his behavior to the child that this ball lives or stays always here. And therefore, this information is very important for the children because they learn a lot about their environment by that sort of interaction with people, especially at that time. And I think dogs, especially family dogs, who are anyway quite focused on their owners and people in the family, they also learn a lot about environment, not by their own experience, but actually by through observing humans and so on. So for example, dogs are not learning about rabbits by chasing them around in the field. They might also have this experience. They are learning about, let's say, rabbits by showing the dog that actually the rabbit food comes from the fridge. So this is a big difference because the concept, what emerges in the dog mind is actually totally different from what I think it emerges or should have emerged actually, or what emerges in a dog or in a wolf that actually is living in the wild and has a real type of interaction with their future food. So I think this is what we have to take in account, that really what concepts are there in the mind are very much depending on the environment and of course also sometimes of the genetic background, what helps in facilitates that sort of understanding. So I think I finish here by saying basically that what I try to suggest you first of all is that sort of critical thinking, and this critical thinking should go also both ways. And by both ways I mean that people who are now in the audience or listening to these talks are actually, in my view, experts who know a lot much more about dog behavior that one scientist can really know anytime, although he has one dog, 2 dogs or 3 dogs at home or tests many. So I think what we also would need is sometimes this sort of feedback that when we are making our experiments and trying to interpret that people have that sort of critical thinking and coming back and not just saying that, you know, you made a stupid experiment or whatever, but actually helping us to make this transition from the experimental situation and arrangement to the people who are working them and understanding dogs in different ways. So I think this mutual interaction is important, and I think that's why Sparks has made a good job in this direction, and I'm sure it will make in the future, because this is what we need. So that sort of discussion is very important, and it's actually very nice because we have a much better chance to understand actually dogs because of that than, for example, people who are investigating rats, because rats don't come with such sort of knowledge on their top. There are no rats trainers out there. They would inform us about many exciting things. So, and sometimes it's also sure that for me and for scientists, coming up with simple models of mental processing is actually not really exciting. So we really should have, the scientist's job is to work more on how to come up with more exciting explanations of the mind, which are not just falling into one or the other club, which I mentioned before. And I really think that here again is an important role for the ethologist to keep this thinking on a track, and by ethology I really mean that we have to have this contact with animal behavior, the natural animal behavior, and of course the natural animal behavior is, in the case of the dog, the behavior in the family, how they interact with people and with other pet dogs in the family or in the neighborhood. So with these thoughts I would like to leave you, and thank you very much for your attention, and I hope we have this critical discourse also in the future. Thank you very much.